Good afternoon, everyone. I hope I am audible to all of you. If not, please raise your voice. Am I audible?
Yes, ma'am.
Yes, right? Okay, very good. Okay, so welcome to the second lecture on operating system, right? So do you have any question from the last lecture? So it was very basic, right, on operating system. So today, basically, what we are going to discuss mainly, we are going to learn mainly one basic thing. Uh, First of all, how operating system uh, virtualizes the CPU. So what is the meaning of that? So last day we discussed, right? So when there was no operating system, right? Then basically we had some human being who used to do all the tasks, on behalf of the programmer, right? So programmer used to submit their program in a tape, right? Then the operator, right, the human being, so he used to take that program, right, which was written in a tape. So he used to load that program first in the main memory, right? That's the first step he will do that. Then, so he need to make sure after loading this program into the main memory, CPU should be able to execute that program, right? Means that program is nothing but set of instruction, right? So at that time you need to write in low level instruction only. So like high level instruction, that maybe that was not permissible in, right? So now how the CPU will start running the program, right? So for that also operator need to do something. Means he need to initiate the CPU. As I mentioned yesterday also, CPU has many registers, right? So what the operator would do, so he would initialize those registers, right? So as I mentioned in the last class, maybe we had some picture also. So let's say this is the CPU or the processor. So it has some registers, very fast registers, right? So one of the register is known as program counter, so which will store the address of main memory from where the next instruction will come, and the CPU is supposed to execute that instruction, right? So this value, unless you initialize it, the CPU will not be able to, fetch that instruction from there, right? Though we have circuitry and all, CPU is nothing but, you can imagine this is a circuit, right? It's a circuit board which has some power, right? Which is a hardware mechanism, basically, right? So not only program counter, there are other registers as well. For example, you need to know from where the data is coming, right? Or you need to store the data. For example, let's say I want to add two data, right? So those two data I should collect it and I should store it in some registers, right? So that the CPU can perform the add operation, right? So, but the basic few registers one should initialize it so that the CPU can start executing, right? So once this is initialized, right, the operator, he then can sleep, because then it's the part of the CPU. He will fetch the instruction one by one from the main memory because it is initiated, right? It can actually perform this. Then once performing executing one instruction, it can on its own it can actually store maybe if it is needed to store in the main memory some data, right? Or fetch something. So that it will do. Okay, so that is if you have only one process, right, or one program and one CPU, right? So and human being can do all these things, right? But so the point is you need to automate this thing, right? So that's the main point of operating system. Operating system is basically it is going to minimize the role of this operator, human being, right? So that he can actually take rest, right? And this operating system is basically the automation version of that operator, right? So now basically, as I mentioned in the last class also, the operator role was not much more when basically we realized that one can actually time share the CPU, right? So at that point, basically you need to understand if you time share the CPU, what is the meaning of that? Nowadays, what we are actually doing, you know that in one machine, you have several application program is running, right? You might run several program on your own one, maybe let's say internet browser is open, another maybe your some music is going on. So right, you can write your own several programs, those are also executed, let's say, right? So it means, but though in our machine, we might have several cores, right? Means cores, processors, right? But in earlier days, in fact, we also used just one processor was there, but we had the feeling that, okay, so so many processors might be there, or maybe the whole processor is for my one program, right? So this is nothing but virtualization of the CPU, right? And this is mainly done by this operating system. Means so now the question is how to do such thing, or how to make this automation, right? So in order to do that, so we learn today how this is done, or what is the basic thing you should do to enable such thing. Okay, so for that basically there is the operating system actually creates one abstraction which is called as process. Okay, so what is process? Any answer? Last day also I vaguely, I think we mentioned what process is. So can anyone tell me what is a process? So maybe informally, can you tell me what is a process? Any idea? So today basically the main agenda is we are going to learn how to do this virtualize, how this operating system is virtualizing these programs. Means, so process is, so the answer is process is a running program, right? So in other words, this is one abstraction which operating system did, right? So if you understand, so we might have several process in my system, right? So as I mentioned, process is a running program, right? Running program. So that is more informally running. So we might have several process running in the machine, right? So if you remember, if you see, I mean, visualize the picture, we have one human operator, right? So which we actually now want to make automate. Instead of human operator, we want to create our own code, right? Who will do the same job like the human operator, right? So now visualize the scenario. I have multiple program, right? So multiple programmers are there. They are in a queue. So I want to time share my machine in between them, right? So how will you do such thing? So if you want to do such thing, the program, the human operator, right? So he need to do some kind of bookkeeping, right? So for example, let's say some program was running in one machine, right? Now, somehow you have decided, okay, that program has run for a long time. I should stop executing the program, right? And I should give another body chance. Another programmer should come and he or she should submit his process, right? Or the program. And we should make that program is running process, right? So in order to enable this kind of thing, means preemption, so it's not only, so if you are going to if you are going to say preempt some program, right, you are stopping temporarily one program, right? So if you are going to do that, then also you need to in future so you of course you need to finish that program, right? So you need to bring back that program into your machine, right? so that it can start from the exact point where it was stopped before, right? So if you want to enable that, so you need to actually do a bookkeeping job, right? So what type of bookkeeping job you should do? You should always remember what was the status of the process when it was stopped, right? So in other words, the snapshot of the process, right? You should remember, so that again, so now you need to actually characterize what type of snapshot, means what type of thing you should actually bookkeep, so that in future when you are actually thinking that, okay, I should bring back that process again from where it actually it was stopped, right, running the CPU, I should actually bring back. So we need to remember all those status, whatever it had earlier, right? So in other words, so we need to do a bookkeeping, right? So for this purpose, basically what we need. So can you tell me how to do this bookkeeping job? I mean, if let's say you are one designer, which is actually whose job is to make this automation. So how would you do such thing if you want to do this bookkeeping job? I hope you have understood what is the objective, right? So you want to automate the system, right? So which earlier actually human being used to do, right? So so for it would be difficult to remember for one human being, right? To if you are going to preempt and all, so that's why the preemption was not enabled during the human era, right? So when we have operating system as a human being was playing the role of operating system, then basically this bookkeeping job would be very much tedious, right? So that's why we had to think about the automation, right? So that means our system can do this. If I want to do that, right, this automation thing, we need to do some bookkeeping, right? So what type of bookkeeping one should do? Can you tell me? Any idea? No idea? So, do you understand what I mean, what is the agenda today we are going to discuss? Is there any question? Because if you don't interrupt, then maybe it would be difficult for me to understand whether you guys are on the same line with me. Is there any question? No question. You thought that you will not interact with me?
Ma'am, could you please
Yes.
just rebrief us on what the question was regarding bookkeeping and those
Acha, you
factories?
didn't. Acha,
It was a bit
okay, good.
complicated.
Okay, it was complicated for you. Okay, so last day you remember, did you remember that we have discussed that in earlier days we had only, we didn't have the concept of operating system, right? We had one human being, he actually used to play the role of operating system, right? So that person was called operator. And as you understood, so basically, uh, uh, why you are actually supposed to bring the operating system into the picture, right? That is one first question. You should understand that why the operating system should be there instead of the human operator, right? So can you tell me that first? Maybe then we will go forward.
Because it's tedious and comparatively expensive and less efficient.
Okay, right. So right, that is one thing. Another thing is, right. So if you remember, so we also mentioned that in the human, so when the operator was human being rather than system, then basically preemption of job was not, I mean, was prohibited, right? So one can actually, so we need to submit the job. The programmer used to submit the job, and operator would load the job, I mean, to the main memory. Then it will initiate the CPU. Then the CPU you will actually start executing the program, right? And until and unless all these things are done, one need to wait, right? Now the objective is to time share the machine, right? In other sense, what is the meaning of time share? Time share means, let's say, we have many programs, right? Or programmers are waiting, you can say, or users are waiting. So, and I have only one machine, right? So it might be the thing that I have one very big job. It is actually running, right? So now it is better not to give this whole CPU time together to one user. Rather, let's say we want to make sure that the CPU time is actually it's partitioned, right? We are giving maybe certain amount of time to some user. If we see that within that time the job is done, then it is okay. Otherwise, we are going to preempt this. What is the meaning of preemption? Preemption means we are actually stopping the job from running, right? So it was running in the CPU, we want to stop for the time being. We are not saying that we are exiting that process. We need to come back. It is actually, it is blocked, you can say. It is for the time being, it is actually, it is removed from the CPU. Now, one new process, we are going to actually, we are going to make a chance for that. We need to give another process the chance to execute, right? So if you are going to do that, again, the first process, which was actually stopped, right, after some portion of time. So we need to bring back that process into the picture in future, right? And we also need to make sure that the process actually starts from the same state where it stopped before, right? So in order to do that thing, so we need to remember from where it started. So we need to remember what should I say, snapshot, right? Snapshot of the CPU registers. Not only that, the snapshot of the main memory, right, of that process, that we should remember somehow. So if you can do, then only you can actually automate the system, right? This is the simple baby step, I should say, right, to automate this system, right? So in order to, so this is basically in order to do that. So what operating system developer will do is basically is so they actually abstract uh, this as a process, right? So what is process? So process is basically one running program. Okay. This abstraction is provided by the operating system. So if you remember, when we have, let's say, I'll just see here, right? So when one program is in running state, right? So then basically one process is created. So this process is created. What is the meaning of that? So it means operating system creates a process and it maintains a data structure corresponding to that process, right? So that one can bookkeep all this information regarding the process, means the snapshot which you want to remember. If the process is blocked or process is, let's say, it is stopped, right? It is not exited from the system. It might come back, but it is stopped temporarily executing from the CPU, right? So one data structure it should maintain corresponding to each of the running program, right? So that is actually nothing but a process. Okay. Okay. And this enables us to virtualize the CPU. Okay. And in order to do so, if you understand, so now the whole scenario is, if you want to enable this automation, then operating system should have some policy, right? So policy means you need to decide which process should run, right? For example, you might decide, okay, so we have so many processes, right? So you can also visualize this as a queue of human being with their programs, right? Now, either you can decide that, okay, the person who is in the front of the queue or the program which came first, that I should execute, right? So this, or maybe I should think about, okay, I can actually estimate, or maybe I can ask the user if they are, let's say, honest user. So they will give some expected running time. Okay, I will decide, okay, the shortest job I am going to execute first. Okay, so this, which policy you should, I mean, which policy means, I mean, this type of policy, I mean, one should have in the operating system, right? Operating system should have some policy to decide which process it should prioritize to the CPU, right? Not only that, also, but also operating system should have some mechanism, as I mentioned, to context switch between the process. There should be some mechanism. Means what is the mechanism we are talking about? Let's say, as I mentioned, let's say I have one process, it was running, right? Now you want to context switch the process to another process, right? So the operating system should have some mechanism to do this context switch smoothly, right? So this is overhead, you can understand. So once one process was running, you have stopped executing it. Based on your policy, right? You might have some policy. Let's say a policy is something like that. If you gave one CPU time of 5 minutes, so it was not stopped. It did not execute. It is not finished within that time. So your policy is to stop it, right? And context switch that process from another process, right? So this context switching, as I mentioned already, you need to do some bookkeeping, right, with respect to this old process as well as the new process. So that the new process might be again another old process, right, which you preempted before. So you need to load it and all, right? So this mechanism, there should be some mechanism. So this mechanism is actually provided by the operating system. Means there you need to write your own code, okay? So there are two types of code you should have. One is for the G policy, right? And another is for the mechanism. Does it make sense to you? So basically, we are going to see which kind of data structure you should maintain, okay, to enable this automation, okay, of this operator. So far, is it okay? So operating system should provide this process abstraction, and it should have policy and mechanism to virtualize the CPU, right? In fact, we are virtualizing CPU means as if you are thinking, the user is thinking that, okay, whole CPU is for me. I am running one program, the whole CPU time is for me. We don't bother about this context switch, right? So this context switch happens, right? Because I have, let's say, only one CPU in my machine and you have so many programs. But we have the feeling, okay, my program is running in the machine, not others, right? So whole CPU time is dedicated to me. So this is called virtualization, and this virtualization, to make this virtualization, actually operating system provides this process abstraction, right? Where you will have some policy and mechanism to do that. Okay. Okay, now, if you understood, now I am going to ask this question. So can you tell me what, if you understood clearly, so as I mentioned already, so process is basically, it's a data structure kind of thing, right? To maintain, the status of each running program, right? You might have many running programs, right? So now the question is, what should constitute a process? So what are the things you should have in your data structure corresponding to process? Can you tell me? Can you tell me what constitutes a process? Just wild guess you can make. No need. It might not be exact answer. I am not asking for exact answer. Can you give some approximate answer? What should constitute a process?
Maybe
Yes,
a
question.
stack of commands and operands.
Stack commands and operands. Okay, good. Right. So yes, Khushi is right. So what else? So this is of course stacks, and what you said, commands means instruction, right? So it means code. And operands. So okay. So right. Right. So in other word, so right, let me draw the picture again. So let's say this is my CPU and this is my main memory, right? And somewhere this is my hard disk, right? So the executable was actually stored in the hard disk, right? So now operating system would load this executable to the main memory, right? Some part of the main memory, right? And so what should be there in that main memory? Do you have any idea? Did I mention that in the last class? I did not say, right? So in that part, right, so that there it should have the code, right? Code is basically static. It should have also some static data, right? Might have, not necessarily it will have. And of course, if you have ever, I mean, wrote any program in C or C++, you know that corresponding to each program, one should have stack and heap also. So now I have question for you guys, right? What is stack and what is heap? What is the purpose of stack and heap? So these are the things which you should have corresponding each running program in the main memory, right? Code means instruction and data means static data. So you might write now you might give some data to your program, right? So maybe initialization, something like that. For example, let's say I have one array. You have initialized all the array element to be 0 or something, right? So those kind of data it should have. So those are static data. So this is taken care of by this part, data part. Then code means the instruction, right? And what is the stack and what is the heap? Can you tell me? So what is the purpose of stack and heap? Do you know this already? So stack is basically, if you remember, so in a program, you might have several functions, right? You might have some jump, right? Functions means you need to jump from one place to another, right? So whenever one function call is there, so you need to remember from where you have come because you need to return there, right? So the stack is basically mainly for that purpose, right? To remember from where you have come. So for that purpose, stack is maintained. And what is the purpose of heap? So heap is basically uh, mm, you might have, let's say, dynamic data structure, right? Dynamically, you can allocate memory, right? Malloc, using malloc, and so, sorry, malloc. So for that purpose, basically heap is used. Dynamically allocate memory. So this heap size is not fixed. Okay, so this is the memory image of a running program, right? So this should be stored in the main memory by operating system, right? So in the process, right? So as I mentioned, process is a data structure corresponding to the process, right? So what kind of thing we should remember, right? What kind of thing we should remember? Should we, so in the data structure, are you going to remember the whole content of this memory image of the process? Are you going to remember that? And if you are going to do that, then how you are going to remember that? So if you understood, the process is a data structure maintained by the operating system. And what is operating system? Operating system is nothing but, again, one software, right? It's a program only, right? So if you are going to remember all these things, means in the process, if you want to remember the code, the data, heap, and stack all together, right? In the process, then the size of your data structure, that would be too much high. So you need to do something smart, right? So maybe you need to remember, so where the code is stored in the main memory, that part you need to remember, right? Where the data, this data part is stored in the main memory, that you need to remember, that address location. The where the heap is beginning, that you need to remember. The stack also, the where the stack begins, right? Or the stack, the top pointer of the stack, you need to remember, right? So this would constitute one part of the process. Okay. In other words, you need to remember the memory image of the process in the data structure, right? Okay, so this is one part. Apart from that, what else would you like to remember in the data structure called process? So if you, I hope you have understood the process of automation, right? Which I mentioned. So that's the objective, right? With that objective in mind, so what other things you should remember apart from this memory? So this is basically memory image of a process, memory image, and how to remember that I already mentioned, right? Memory image of a process. That is, of course, that constitutes the process. What else constitutes the process? Can you tell me what else we should remember?
We will also need to have some sort of a pointer so that what was the last executed instruction.
Right. So that's come from the picture is CPU, right? So as I mentioned already in last class, there is in the CPU you have program counter, you have stack pointer SP. So this program point counter is PC, right? So it actually stores the address, the current address from where the instruction is coming, right? So means this is, let's say, code. So this address is actually stored in the program counter. So if you the status of the process is basically means you need to of course remember what is the current program counter, right, corresponding to that running process. That you need to remember. Not only program counter, but also other registers, some specifics. For example, stack pointer. What is the stack pointer of that process? Means where, as I mentioned, you need to have a pointer to the stack, right? So this information, stack pointer, other registers also, those values also you should remember. So right. So this is also part of the. This also constitute the process. So in other words, we already answered. So memory image is one important thing. And second important thing is basically the CPU context, right? Sorry, CPU context means the registers, right? The value of the registers, whatever you have, that also you should remember. Is it enough? What else we should remember? Is it enough? What else we should remember? Means corresponding to process, what else we should have apart from these two things? So Khushi correctly mentioned. So you should have the memory image, we should remember, means address space of the process, right? And the CPU context of the process. What else we should remember? What else? So is it that we only run the program in the CPU? We also do I/O, right? We need sometime we print something in the in our monitor, right? Or something. Sometime we also need to write something in the file, right? So not only that, if you remember, we also sometime it might have some error message, and that error message is also printed somewhere, right? So for this purpose, we need to have, so what is the status? Which are the file location where you are going to write that pointer? So that status also one should remember corresponding to that process, right? What are the file descriptor? For the open file, what about the open files pointer? Open files pointer. Open file pointers. So these are the main three things, right? Okay, apart from that, anything else would you like to remember for the process? What you should think that what another important thing one should have. So let's say I have one process, right? So I want to distinguish my process from another process, right? So how to distinguish it? So it's since you are computer, I mean you are doing computer science and all. So I think this question is very trivial to you. So there should be unique identifier, right, for corresponding to each process, right? Otherwise, how will you distinguish that this is, how will you know that this process is that and that process is that? So we can do that using unique identifier, process identifier, right? So that's the PID, we call it, okay? Okay, so this is one part. Second part, as I already mentioned, memory image and the CPU context. So these are the three important part, and the file descriptor is the third part, right? Okay, that's all basically. A process means we should have corresponding to that process, every process. We should remember these things. Okay. 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 Now the next question is, how does operating system creates a process? Okay. I think I have already mentioned this, but let's see the diagram once again. Okay, as I mentioned already, right, this disk is basically the hard disk, you can imagine. So operating system basically make one program to a process, right? This conversion is done by the operating system, right? So in other words, if operating system wants to create a process, then it should load the memory, load the process. I mean load the process to the main memory, right? Means code, static data, that thing, and of course it should give some part for stack and heap, right? So this is the memory load part, right? So after that, what it should do, the operating system should do corresponding to process, of course. So if one wants to create a process, first thing he should create one unique identifier for that, right? That is the first thing. Next thing is you need to actually load the image to your to the main memory, right? And so initialize this CPU thing, right? CPU, the register, whatever the register you have in the CPU, right? We need to initialize it. For example, PC program counter, you need to initialize with the starting position. Let's say this is main function is there, so the starting position of that you need to give, right? Right. So once you initialize it, then basically now operating system can actually go for a sleep as if, right? And the CPU will execute on its own, right? Does it make sense? So in other words, so operating system is actually creating one. So not only that. So if you understand, so we have a data structure. We need to initialize all these things, right? In the data structure, we need to give a PID, right? Then we need to in that snapshot, whatever the things you have corresponding to CPU, right? That we should remember, right? And the file descriptor, whatever you have, for example, standard input, output, those things are there, right? Standard input, output, whatever you have, error, no? Those files descriptor, the pointer, you should remember from where it comes, right? So this is the step. So this is the first step, allocates memory and creates memory image, right? Okay, it creates runtime stack and heap, right? And then opens basic file descriptor corresponding to that process. Then initialize the CPU process. Then basically it's done. Then basically you don't need to worry about, operating system will not worry. Then this CPU will execute the process. Okay, operating system will not need to do anything. Okay, I hope you have understood it. Now, do you understand? Now the question is, so if you understand, now operating system forgets about it, right? Now the PC program counter will be changed, CPU context will be changed, right? One after another, because the instruction is running, right? Different instructions are run, right? So program counter value will be changed. Of current operands, whatever that is also, that will be changed. Stack pointer might be changed, and it is changed. So I mean, in a fraction of second, right? Not even that. So now the question is, so that question I will ask you. The answer is not here. So is it that frequently do I need to update all these status to the data structure which we have corresponding to that process? Do I need to maintain all this change? After each change, the CPU, I mean, if you understand, so if you understand the picture, so operating system basically creates a process. So this means it actually make one data structure. If you have some data structure corresponding to that process, and there basically we are going to remember all these things. You have created one unique identifier for that process, that is some number, that's it. And we are going to remember where we have loaded that process, right? That memory image, the address of this position I have remembered, the code, the static data where it is stored, somehow I have remembered, right? The stack pointer and all those things. CPU context also I have remembered, right? For the initial configuration, right? Now I said that, okay, after doing this, operating system can forget about that process. CPU will actually execute that process. Now operating system can, I mean, ignore. So now the question is, if you understand, right? So as I mentioned, the CPU context will be changed one after another. if you are going to execute the program. The CPU is running, right? So the question is, when should we make an update for this this content of the process? Means the data structure, whatever the values we had, right, initially. So should I update it once this is updated in the CPU? CPU status is changing, right? It is ever changing when the program is run by the CPU, means the process is run by the CPU. Then the status, all these status might not be changed, but CPU context will be changed, right? After each execution of the instruction, right? It will be changed. Now, would you like to update this information in the data structure every time? So if you are going to do that, that is a headache of the operating system, right? It is extra work you are doing. You need to remember, then it would be slow, right? So we generally don't do that all the time when the CPU, I mean, the context, I mean, what should I say? After each instruction, the CPU context is changing, right? Right? PC value will be changed. Current operands value will be changed. Stack pointer might be changed, right? All these things are changing. But we are not going to update it. Okay. So when we are going to update? Can you tell me when we should update? Any answer? No answer. When we should change it? Khushi, can you tell me?
I don't know, ma'am.
Did you understand the question?
Yeah, I understood. Like, if we update this with every single operation, then that would be very tedious and a lot of memory would be taken.
Right. Then the question is, when should we change? Or we should not change at all. So the initial configuration is, I mean, we have stored that's enough for us. Is it the case? Then it's not that process, right? After some time, it is not corresponding to that process. You have remembered, you have bookkept something, right? And after, I mean, it is not the status, whatever you want, right? So when should you change? Okay, so you can, so the answer is basically when you are going to context switch between process, then only you should change it. Otherwise, you should not do it. Okay, so that's the answer. Okay, we'll discuss this context switching mechanism in maybe next class. So that's the answer. There is no answer in this slide. Okay, I hope you have understood it, how the process is created by operating system. Okay. Okay, now let us see the states of a process. Okay. So if you see the picture, this is the picture. And if you think about the situation, this is basically time sharing environment. We have many processes, right, in the picture. So now what could be the states of a process, right? So it might be the thing that one process, it is now run by the CPU. Okay, at present the CPU is actually running that program, running that process, right? If that is the case, then that is the most active process right now. Okay, we will refer that process as a running process. Okay, the state of the process is basically we will define it as running state. Okay, so now the question is, what could be other state possible? Okay, this is one state, right? Any other idea what could be other state of a process in the time sharing environment? Okay, this is very much obvious. So one process is running, right? I might have several processes waiting, right, for to make the CPU time, right? For the CPU it is waiting, right? So it is almost all the thing is ready. So it is ready to run. Basically, it is just waiting for the CPU. So for its turn. So that is basically nothing but that state. If that is the status of that process, then we will be referring that process as ready. Okay, the state of the process is basically it is ready. So it is basically just waiting to be scheduled by the operating system. Okay. Okay. So another state, or another, what could be the another state? Can you tell me? Running, ready. What could be other state?
Reading
Any
some
ideas?
data.
Huh?
Reading some data.
Data means I didn't understand, Dharmendra. So
reading some disk.
reading, okay, acha, acha, acha. So reading something from the disk. Acha, so it is not run right now. Okay, okay, so good. So yes, so if that is the thing, so you understand it is not ready, it is not run by the CPU, right? So it is doing something else, right? So with respect to CPU, we will be defining that process, the status of the or state of the process as blocked. So it is blocked from running. Okay, so that's the third, right? So you have correctly identified this. The third state could be blocked. It is blocked, right? Or suspended. Suspended. It's not ready to run. Okay, it's a status or state of the process which is not ready to run. So as Dharmendra pointed out, it could be the reason that it issues some read or write operation from the disk, right? So until and unless that read write operation is finished, that IO operation is finished. So this is just one example. It could be for various reasons the process is blocked. Okay, it is not the only reason. So that is one state of the process. So if it is not ready to run, but it is also it is also not the dead process. Okay, it is suspended. Okay, kind of thing. It is if that is the state, then we will be referred that process to be a blocked state. Okay, apart from these three, do we have other state? Do we need to maintain other state? So these are the three state we should maintain, right? For sure, running, ready, and block. Okay, these are the three state of a process. We should remember about the process, whether this is a running process or ready process or block process. So is there anything other than these three possible?
The
Anything other than
that have been executed recently.
That okay, right? So that means this is a dead process, right? It's a dead process. Good. So right. So that is also another status. So we should remember whether the process is dead. Dead means it is actually it has completed execution, so it is dead, right? Okay. So apart from this, so of course, if you maintain one status to be dead, then we also should remember whether the process is just newly created, right? So just newly created process. Okay, good. So new, that is another status, as I mentioned, being created. It is just being created and yet to run, right? Another state might be it is dead, means it is terminated. Okay, so dead, it might happen that the process terminated on its own, or maybe somebody forcefully terminated, right? Both the things are dead. Okay, now if you see the state transition diagram, it's actually very simple, right? So you can see if some process is running, it might be the case that it is basically descheduled from the CPU, right? And it is just removed from the CPU to make a space to other process, right, to the CPU. So then it will be in the ready state. It will go to the ready state, right? And okay, from the ready state, it might happen that okay, it will again get after some point of time, somebody will get chance from the ready to run state, right? It will run, and in the meantime, if it invokes some IO operation or something like that, then it might be blocked from running, right? And it will be in the block state, right? And once this IO operation is done for a block process, so it can actually it is not. I mean, you can't make that blocked process to running state directly. Okay, this is prohibited. If it is blocked, then basically it means its IO is done. It need to be in the ready state. Okay, that in there it will be waiting to be scheduled by the operating system again. Then it will again come to the running state. Okay. So again, so for if a process is terminated, then it will actually from running, it can be terminated. Okay, not necessarily so that termination status or the dead status. It can actually happen from running, from blocked or somewhere also, right? As I mentioned, it is a forcefully also you can terminate one process, or from ready queue also you can actually make that to terminate. Right, all the possibilities are there. So that's why there is no state. I mean, in this state transition diagram, we don't have. I did not mention that termination as well, another state, how to go to that state. Okay, it is trivial. I mean, we can go from running to termination, from block to termination, or ready to termination as well, right? All these things are possible. And if a newly created job, right? So again, newly created job also, so one should have, if it is a newly created job, it should be first in a ready state, then only operating system will decide when to schedule that job, right? Then it will be in the running state. Okay, so in other words, you can visualize, so a running is basically just one process will get that status at a time, running, right? All other process, though they are, I mean, running process informally, they are basically either in ready state or in block state or maybe dead state or something like that. Okay. Okay, so in pictorially, basically this is just one example. So for example, let's say I have a process 0, so it was running, right? I have two processes, let's say in the picture. Another process is process 1. So this was running, then it might happen that it actually completed that program, right? Running the program. Then the second process will get his chance, then it will run. So it was until and unless it was stopped, this second guy, means process 1 was actually ready. It was ready to be scheduled by the operating system, right? You understand? Then after this process, this is one possibility. Another possibility, I mean, there could be several possibilities could be there, right? So it might be that the process 0 was running, then it initiates some IO operation at this moment, right, at this time. So then it was blocked, right? It got blocked state, and the process 1, it was ready actually. So at this the moment when it initiated, the other process initiated the IO operation, it got the chance, so it was run, right? And when the other process, you can see the process 0, so it was blocked, it was doing the IO operation. When the IO is done, so it will actually give a signal, and its status would be changed from block to ready, right? And the operating system will decide when it is going to make it running. So this is another possibility. It's just example. There could be several possibilities. Okay. So now let's see if the data structure corresponding to the data structure which operating system should maintain to enable all such things, right? So in other sense, yes.
When a process goes to a block state, is it restarted or is it resumed after the blocking is done?
So it will not go to the running state directly. So once the block once the process was blocked for some reason, right? So maybe for IO region, IO is done, then it will get some signal that IO is done. So then the status would be changed from block to ready. Until it is ready, operating system will not take it for consideration for the scheduling. Okay, so scheduler will only schedule those processes which are ready to run. Okay, which were in block state, but it is not even ready, so it will not consider. So this ready state should be there, block to ready, just to make the scheduler that okay, this guy is also ready, I can schedule it. Okay. So after ready, only it can be in the running state. So that's why this diagram also, if you see, it was blocked. So it is not, I did not give one arrow like this from here to there, right? This is a prohibited array. This is a prohibited array. Okay, everything changed. Okay, I see. This is a prohibited array, right? Direction. So basically from block to ready, you need to go. Does it answer your question, Akshay?
Ma'am, I wanted to ask, let's say there are certain instructions in a process. It is running.
Okay.
Only some of the instructions have been completed and then it is blocked.
Okay. So okay, it is completed, then it is blocked. Okay, why this is blocked?
Some of the instructions have been completed, but some are.
Okay, okay.
So
it is
blocked. After some instructions, I blocked it. So when I make it ready again, do I need to restart all the instructions or can I resume? This was my question.
No. Okay. That was your question. Okay, didn't understand. I didn't understand your question. No, so blocked means, blocked means, as I mentioned, no, it's not that thing that it will actually start from the beginning. No, it will actually start. It will resume its process. Okay, it has finished. Okay, block means it for some purpose only it was blocked from the CPU, because for example it might be waiting for something to happen. Okay, so that's why it was blocked. Something to happen, that's why it was blocked. So when that something is completed, then it is actually unblocked, means it is from block to, it gets the status from block to ready. But when it will be executed again by the CPU, then it will start from the point where it was stopped. It will not start from the beginning. Okay. Okay. Good. Any other question? Okay. If not, then let's see what is the data structure. Any other question? No question, right? Okay. So basically, if you understand now the scenario, so operating system should maintain a list for all this active process, right? In other words, it should maintain a data structure that is nothing but a list for all this active process, right? Does it make sense to you? This is the first thing, basic thing one should have. Okay, so another thing which I already mentioned is basically now we also mentioned, right? So the corresponding to each process, we should have a data structure, right? So or corresponding to each process, we should maintain the information corresponding to that process, right? So that sometimes we refer as PCB, process control block. Okay, this is nothing but a data structure, right? Which I already mentioned. So in that PCB means process control block. There basically we remember process identifier, the process state of the process, right? So as I mentioned, there are 5 states, right? So what is the current state of the process, that we need to remember. And another important thing which I did not mention, that is basically pointer to other related process, that also we need to maintain. Okay. For example, it might be the case that the current program is actually the parent program. So it creates some child program, right? So the child should remember from where it was created. The pointer to the parent, it should remember, okay, from where it was created. So similarly, the pointer to the child, that is also there with the parent. That should be there. So this kind of information means the pointers to other related process, one should remember in the process control block. Okay. And not only that, we have already mentioned CPU context of the process also one should remember, and pointers to memory locations and pointers to open files. These all the things which we discuss. So that is basically, it's one name is given, just PCB, process control block. That is nothing but the data structure corresponding to your process, right? There, these informations are going to be stored. Okay, so now let us see one example. I hope you have understood the data structure. Now the question is how you can create such data structure. Can you tell me? So, so this is, as I mentioned, this is just very basic, right? So here we just discuss about what kind of primitive you should have if you are going to write one operating system code, right? One program for operating system to virtualize the CPU, right? So the first basic thing is you need to have some data structure corresponding to process, right? And you should also maintain a list of the process, right? So that one can maintain by list, right? Linked list or something like that. Okay, or maybe list, just list. You can create one list using array, right? So array of what? So this process, the data structure corresponding to process, how would you create it? If you are going to write your own program for your operating system, how do you create? What should be your data structure? Everybody should answer this. There should not be any fail. How to maintain this? Can you tell me? What kind of data structure should have? No answer? First of all, let me know whether you understand the question. Did you understand the question, what I asked right now? Ayush, Akshay, I can see these names are coming. Dharmendra. So this is right. Any other guy? Yash, Khushi.
Ma'am, once you like you have already mentioned that we have to use list. So I actually
right. You didn't understand the question. So yes, list of what? List of what? Now that question is list of what? So this actually this is very straightforward, right? So you need to create. You can actually maintain all this thing using structure, right? Structure is one primitive which is available in C, C++, right? So using structure, one can remember all these things. So you structure it in the structure. You can have several variables, right? One variable corresponding to, let's say, this is just one example, but real operating system code that you can actually visualize, right? That is for open source and all. For example, Unix and all. So they have open source. You can visualize the code corresponding to each process, right? So this is just for the, let's say, if you want to remember the context of a CPU, right? So context of a CPU, it corresponds to actually you need to remember the register, the CPU, whatever the CPU register we have corresponding to that process, right? That status you need to remember. So you can actually remember using several variables, right? So this structure context, it corresponds to remembering the context of a CPU corresponding to that process. Okay, you can do that. Similarly, let's say we want to remember the state of the process. So state is basically, if you remember, we have a running state, right? And runnable means ready state, right? Here basically they have mentioned more state. For example, sleeping state, embryo state, unused state. These are zombie state. What is zombie? Zombie is one process is dead, but it is not cleaned up, right? So for example, let's say I have a process, right? So it is terminated successfully, but unless you clean up the space used by the operating system, for example, when the process was active, right? So it was taking the space corresponding to its own data structure, right? So for example, the space of the context, right? All these things were remembered somewhere. So you need to clean it up. You need to actually clean up the memory corresponding to that process, right? So unless you do that, dead process is a zombie process. Okay. Okay. Right. No, I think I did not state it correctly. I'm sorry. No. Zombie process is not like that. Zombie, I'm so sorry. Zombie process, right. So I just made a wrong statement. Okay, I'm just taking back my words. So when one process is terminated, right? So if you understood it, so we need to clean up its space used, right? For example, the space used for the data structure for the corresponding to its process, right? Whatever the space it was reused, right? Or maybe the memory image also it is there, right? So we need to clean up. Now the question is how you are going to clean up these things. Who should clean up, right? That is the question. Can you answer this question? Then I'll define this zombie. Can you answer this question? Do you understand the question? Right? So let's say one process was there. So it ran successfully, right? So now it is dead process. But even if it is dead, so some memory space is taken by that process, right? For example, we had a process identifier for that, and all the informations are stored by the PCB, right? PCB, there is one space which is actually occupied by for the PCB, right, in your data structure. Also, the real image of the process is also might be stored in the main memory, right? All these things are there. Now, somehow we need to, if you want to make your system faster, you should clean up this memory. Otherwise, it might happen that you had so many processes which ran earlier and all the processes are dead, right? None of the processes is active, but the memory is actually occupied by all these dead processes, right? It might happen. So then if that is the case, basically, then the future process will actually will run out of memory, right? Or in other words, the system will be slow, right? So in order to avoid that, so one should actually take the responsibility to clean up the memory space used by the dead process, right? You understand this? So basically this operation is actually taken care by the parent of the process. Okay, let's say some process was dead, so we know that's a parent, right? So parent, before it dies, right, so it will actually take the responsibility to clean up the memory space used by its child. Okay, so now it might happen that the parent actually parent is dead before its child. Okay, so in that case, the child process is now zombie process. Okay, so because its parents is dead. So if that is the case, then we should remember that the status of the process is basically zombie. So if that is the case, so who, now the question is who will clean up those zombie process? Okay, so now can you answer who will clean up the zombie process? Do you understand who is zombie? This zombie statement is clear to you? Zombie. Did you understand zombie?
Yes,
Ayush, did you understand? Akshay? Okay, good. So now the question is who will clean up the zombie process? So the zombie process are basically headache, right? So because they are dead, but their parents also are also dead, and in fact they died before the child, right? So the parent actually should take the responsibility to clean up the memories process or all the process, but unfortunately it is not the case for the zombie process. So in that case, so we have some headache, extra headache. Now the question is who should take the responsibility for this zombie process, means to clean up the zombie process? Of course, the answer is operating system should take. So in other words, there is one, there is one parent of all the, there is one common ancestor actually basically for all the process. Okay, so that process is called init. Okay, so this is called init. So this is basically ancestor of all the process. Okay, so there is parent-child relationship in between all the process, and that is basically you can visualize that as a tree only, right? Okay, init is the ancestor of all. So in that case, for the zombie process, init will take the responsibility. Okay, it will clean up the memory space used by zombie. It will clean up. Okay, or init will take the responsibility. Okay, that's why this zombie word came. Okay, okay, good. So I hope you have understood. This is just simple example. The real operating system code might be too much complex. Okay, this is just for your understanding purpose. I mean, so that you have the feeling. Okay, you also can write your own code for the operating system. Okay. Okay. Now now you see the proc structure corresponding. So this is the PCP basically. So there you have a pointer to memory, right? Start of the process memory, wherever it is. Then you need to have the status, means state, proc state, which we have mentioned here, right? That also you should have. Then you should have a pointer to the parent, right? So pointer means parent is again proc, right? Proc structure only. Then if it is a sleeping process, then we should know where it is sleeping. Okay, and if the process is killed, then also you should remember whether the process is killed or not. If it is non-zero, then basically it is killed, otherwise it is not killed. Okay, and also we should have a pointer to file structure. You can see this is very simple example, and this context of the CPU, right, which we have defined earlier. So that also should play one part of the proc structure, right? And other things, these are not the only things. Okay, there are many other things also, so which we will see throughout our curriculum. So we will see many more things we should remember corresponding to one process. So these are not the only thing. Okay, I am saying these are not the only thing. This is just the thing corresponding to CPU. Means if you are going to virtualize the CPU, then these are the things which you should remember at least. Okay, there are several other things too corresponding to one proc structure. Okay, so that we will see one after another throughout our course. Okay, if something is coming. Okay, means in details basically, nothing else. So for example, what is this, right? So when we'll see file system, then you will understand it in more detail. Okay. For example, sleeping, how, when and how, why do you need that some process will be in sleeping state? So this is not clear right now, right? But we have some of the, part in the proc structure there. So this will be clear in, subsequent lectures. Okay. Okay. Okay, I think that's one part. Do you have any question for this lecture? Do you have any other question? Do you understand everything? I have 15 minutes left. I can actually, I don't know. I'm thinking whether we should start one new chapter or this is. So do you have any question? Anyone have a question? Do you have any question? Yes, Akshay has some question.
Ma'am, how do you mention the start of the process memory, and in case the memory that is allocated has to be increased, so can it be done in real time?
So say that once again.
Ma'am, first of all, you mentioned in the struct proc, in the slide you have mentioned that we have to mention the start of the process memory and the size of process memory.
Size of the process. Okay. Did I mention the size of the process? What is the meaning of size of the process?
Yeah.
Acha, size of process memory. Acha, ठीक है. Size of process memory, yes. So start of the memory you are writing, right? Then what is the? So it's just okay. So as I mentioned, this is just for the time being we are saying. See, when we will see the actual memory management, then you will see the difference. It's not the only thing. Okay, for the time being, you can actually visualize. We should remember where we have stored, we have loaded the process in the main memory, right? Here the process in the main memory means what should I say? The memory image of the process, right? We have some memory image, so we should remember the starting position and the size. If I remember, then we will be able to justify up to which portion this process is allowed to read from the memory, right? So each process has some private part, right? So we should actually protect other process to stop utilizing or reading their private part of the memory, right? So to stop that, we should know the starting position and its size, right? At least this much of information we should actually take care of. So but so do you understand this? That's the reason basically, because we have so many processes. Now we need to stop other process to disturb one process private memory, right? It should not be allowed to rewrite or maybe modify or maybe even just read. That is also not allowed, right? So that for that purpose, basically we are keeping that. But this thing you will see in more detail. So for the time being, what we said here, right, is not enough. You will see when we will see the memory management, then you will see this part in more detail. In fact, so for the time being, we actually take it for granted that whole memory image is actually loaded in consecutive part of the main memory, right? That is the picture over here. But this is also not the thing. This should not be the case basically. So that will be we will see in detail when we will see memory management. Okay. So this is just one representative picture. It is not the actual picture. We'll see. But one can do in this way also. So this is not wrong. Okay. One can do this way also, but this will not be efficient memory management.
So
okay.
In case if I have to increase the process
right.
right. So that entire space will be void.
Right. So that's yeah, correct. So we'll see how to manage this. That's a good question. Keep this question or maybe this inquisitiveness until we explore the memory management. Okay, that's a beautiful thing we will learn when we will discuss memory management. So it's not the thing that this, because if you see, if you are going to decide that from here to there, this whole chunk of memory is given to a particular process. So it might be the thing that the process is actually running out of memory, or maybe that process is actually given too much of memory, which is actually wasted, right? So it's not a good idea to decide the size on before, right? So in the real time, actually, you need to decide what part, which part, how much amount of memory you should allocate to a process. In fact, one should not allocate whole part of code to the main memory for a process. Okay, it is actually part by part it should come, right? So we'll see this in more detail in memory management. So currently actually, so this today's discussion is more on the CPU management. Okay, means right, virtualization of the CPU. In the next class also we'll see how to. So here we have actually learned only the basic concept, means the data structure corresponding to process, right? In the next class we will discuss some APIs, right? Means application programming interface. So those which the programmer or the user program are allowed to invoke. Okay, maybe the question which I want to ask you something like this. Let's say, is it the case that your user program, right? Is it okay if I allow the program to run on its own? Is it okay if I allow, let's say I have one program, I have written one program, and some instruction are given to it, right? If you have some executable, right? And so basically it might have, we might write something right over that instruction and all. They are somehow, maybe I am writing that I am going, that program is going to read some private instruction or private data from the operating system, or maybe private data of other process, right? Is it allowed? How will you protect that not to do that? Some process should not do something like that, right? It should not change other process memory image or maybe instruction or whatever, right? It should not read even, right? How will you stop doing that, right? Any answer for that? So any answer? How do you stop process doing anything from the system? Do you understand the question? So I might have some malicious program, right? So that might run, and that might actually steal my information, other process information. So I should stop somehow, right? The operating system should be actually, what should I say? It should be robust, right? And it should stop such kind of thing, right? How would you do that? Any idea how to do that? So that maybe I will ask. I'll stop after getting some answer from you guys. Any idea? Do you understand the question? Akshay, did you understand the question?
Ma'am, but if the space is private, how are they able to access other processes' memory? You already said those attributes are private to the particular process. No other process can access that. So how
right.
So how is it possible that one process can access the space of other process and modify the file?
That's a good question. So, okay, you did not get it. So, for example, let's say I just, or maybe I have some other process. Somehow I know that this process is stored over that memory, right? And I want to read what is written over there, right? That kind of instruction. I might actually want to read. This is nothing but reading data from some part of the main memory, right? So some instruction I have given, so that the purpose of this is basically read the data from the private part of the memory. So just address location I am given, and I want to read it, that process, right? So is it allowed? It should not be allowed, right? Means, in other words, so that is nothing but saying that, okay, the process should not be allowed to run its own code on its own, right? That much should be, you should understand that, right? So there should be somebody who should actually control, right, executing the process. So in other words, for example, let's say, in fact, if you see the picture, when I said that after loading the program into main memory, right, and initializing the CPU, then basically operating system actually can take rest, means it can ignore about what is taken care of the CPU and memory, right? Is that okay? But now let's say in the program itself, there are some what should I say, some kind of restrictive instruction are written, right? And CPU doesn't know, right? Because now the CPU is actually one hardware. So it actually knows that, okay, this some instruction are given and my task is to run it one after another. That's it, right? So some misleading instruction might be there and CPU knows, okay, it matches with the instruction set. I will just execute it after decoding. That's it, right? It can do it. Now the question is, how do you stop executing some what should I say, some important instruction which should not be executed by some simple program? Okay, how do you stop doing that? Yeah,
privileging certain rights for running the process. If
okay, good. Yes, that's the concept. Now the question is, how will you make that privilege and unprivileged? So in other words, yeah, that's good. That's the thing basically. You want to decide that which instructions are privileged instruction and which instructions are not privileged, right? So right, that's the answer, right? Akshay, you are right, very right. So basically to do that, so there is actually hardware support for this. Okay, so initially the CPU, so when one program is run on behalf of user, right, or on behalf of a program, so basically CPU will be run in user mode. Okay, so in that mode you can't execute privileged instruction. Okay. Now, if CPU sees that some privileged instructions are there, right? So basically, then the control is not with the user. Then operating system will take care. So it will the program is actually then taken care of the operating system. Okay, it will realize, okay, this is a privileged instruction. First of all, operating system should check whether that privileged instruction, should be executed by that program or not. Whether it should allow it or not. So to do that, basically it decides, okay, it is executable, it is permittable instruction, then only it should give permission to CPU, means it will change the hardware controls. So hardware, as I mentioned, there should be some bit. So 1 bit is actually for, let's say 1 bit is enough. So if it is, let's say 0, then it means that it is in the user mode. If it is 1, then it says that it is in the privileged mode. And in the privileged mode only, hardware can execute that certain privileged instruction. In this way, one can actually protect the right of a process. Okay. In fact, even the command like printf and all, these are actually privileged instruction. Okay. So it is not permissible by the user. Operating system will take care of that. Means you need to make the CPU in the privileged mode, then only it can do that. Okay. So these questions, along with this, I mean, so now the question is, what kind of privileged instruction or privileged? So in other words, then your user program can't do much, right? So all the power is with the privilege. All this, in fact, this simple thing like print, that also you are not supposed to do on your own. Operating system will take charge, and that is actually the CPU will be converted into privileged mode, right? So, so basically, you are stopping your user program to doing some kind of this thing also, right? Now the question is, how will you manage such thing, right? So in other words, so there should be, operating system should have some interface, right? Certain interfaces, which interfaces basically programmer can actually write in their program. Means there should be some functions which are too specific to the operating system, but those functions, I mean, the user are allowed to evoke those functions. Okay. Those are called system calls. We will see in this detail what kind of system calls are there corresponding to process. Okay, for example, if you need to create one process, so that thing. So, for example, let's say I have a program, right? I am just a programmer. I have written some program. So in that, I want to create one process for some purpose, right? So that should be one privileged thing, right? So operating system should support to do that via giving some interface, right, which are allowed to evoke from the users, right? Not execute. They can't execute on their own, but they can evoke that function. So these are called system calls. So we will see in the next class what type of system calls are available, at least in Unix environment, for managing these processes. Okay, in detail. That we will see in the next lecture. So do you have any other questions? If not, okay. Let us just wrap this up, what we have learned today. So we have just learned mainly one main thing, what is the data structure corresponding to a process, means how operating system virtualizes the CPU, right? And for that purpose, what specific data structure, what are the status you should maintain, right? And what should be the state of different processes, right? These are the main things which we have learned today. So this is very basic. I hope you have, learned all the things, right? You don't have to reread it once again, right? Do you have any other questions? So in the next class, we are going to see in more detail. So what are the application programming interface? In other words, what are the system calls available to manage processes? Okay, and that one can execute. In fact, you also can write your own program and evoke these system calls. Okay. Okay. Any other questions? Do you have any questions? No questions? Then maybe we can conclude. If you don't have any questions. So we'll meet again on Tuesday, right? Tuesday, 5:30. Okay. Any question? I'm just waiting for question. If you have any questions. No question? No question, right? Okay, thank you guys. We'll meet again on next Tuesday.